Last lecture, I think we have seen finding out solution set for different algebraic inequalities. We will do more sums on that, more sums on that, and try to understand how do we go about solving algebraic inequalities. Still students are joining and still are keeping their videos off in spite of the fact that I have asked you to put it on, else I will remove you from the meeting. Okay, so scanning from left to right and understanding the wavy nature of the curve, because we have dealt with and polynomials are very good functions, they are continuous, etc. Therefore, it was easy to sketch last lecture's inequalities. Let us begin with new inequality example number 1. Suppose I say x minus 3 upon x minus 1 should be less than or equal to 3.
सर
Yes.
सर माझ्या घराची लाईट गेली आहे तर थोड्या वेळासाठी व्हिडिओ ऑफ ठेवला तर चालेल का?
Oh, ठीक है. Okay.
आली की परत चालू करतो मी.
Okay. Solve this problem. X minus 3 upon x minus 1 should be less than or equal to 0 for find all values of x. Find all real values of x. Let me explain you the method. This is something which is critical. You need to understand what we are doing. First of all, you cannot cross multiply unless and until you know what is the parity of x minus 1. If x minus 1 is positive, yes, you can cross multiply, inequality will continue to remain same. But if x minus 1 is negative, then inequality will flip, and therefore it is always ambiguous. We can do either cases, but then handling different cases or more complicated problems is going to be difficult. Therefore, if you are starting with cross multiplication, then it is not correct. Anyway, RHS is 0, so this will get vanished and you will end up getting solution set for x minus 1 less than equal to 0, and it is going to be wrong solution set. Therefore, the trick here or a technique here is you cannot cross multiply because you do not know the parity of x minus 1. Therefore, you multiply by x minus 1 and divide by x minus 1. Therefore, you make a square out of it is less than or equal to 0. Now you are sure that the denominator is positive. Now, can denominator be 0? No, denominator cannot be 0, because if this question is given, even if it is not stated, it is, if x is not equal to 1, it is there, it is, whether it is written here or not, it is understood by the question. If the question is correct, x must not be equal to 1, otherwise it is undefined, it is not a correct mathematical problem. Therefore, even if this, if x not equal to 1 is not written here, still it is to be assumed that because x minus 1 is in the denominator, x must not be equal to 1. It is not in the domain. X is not there in the domain of definition of this function. Okay, x minus 1 is not 0, and hence its square is non-zero and non-negative. Therefore, you can cross multiply. That makes the inequality x minus 1 into x minus 3 should be less than equal to 0. Now, there is a difference between this inequality and the inequality which we have solved last lecture. First, hollow circle at 1, hollow circle at 3, leading coefficient positive. So if you start from left of 1, you will get positive. You will end up going towards positive infinity. You will cut 1, go here and go this way, because it is a standard parabola. right? And you are interested in values of LHS which are less than 0. So you will be interested in this. Now, if we are solving this problem per se, only this problem, then equality will make both these circles dark circles. However, we are not solving this problem, we are solving this problem. And therefore, 1 will never become dark. Because if I make x is equal to 1, the problem itself is undefined. So 1 will continue to stay hollow. Okay? And 3 will become dark. Therefore, solution set is open interval 1, comma 3, closed interval. That is what is your solution set. Have you understood? So the trick that I am showing you right now is how do you ensure that your denominator is positive? You multiply by whatever denominator you have. If you are not sure about the sign of your denominator. If you are sure about the sign of your denominator, that it is either positive always or it is negative always, then you need not have to worry. You can, if the denominator is positive, you can cross multiply and the inequality will continue to remain same. If denominator is negative, you can cross multiply and flip the inequality. That way we can deal with these inequalities. Let me make this problem little difficult now. Example number 2. X minus 3 upon x minus 1 into x minus 2 should be less than or equal to 0. Give me solution set. Okay, let me explain. Majority of the students have shown it correctly, did it correctly. Again, the same principle, you cannot predict about your denominator, you have to make it positive. Therefore, you get x minus 1, x minus 2, x minus 3 divided by x minus 1 bracket square into x minus 2 bracket square should be less than equal to 0. That makes it x minus 1 into x minus 2 into x minus 3 should be less than equal to 0, which we have drawn last lecture. However, there is little difference. Again, draw x-axis, mark critical points with hollow circles. Leading coefficient, if you take extreme left of 1, then all three brackets will be negative. So the graph will enter like this. We will decide about 1, 2, 3 what will happen, but it will go like this, it will go like this, and it will disappear towards positive infinity. That is the nature of LHS. Now you are supposed to find out less than or equal to 0. So first, if you handle less than only, then the solution set is this. Okay. If you want to handle equality, then you might be tempted to do all these three circles dark circles. But then we are not solving this problem, we are solving this problem. Therefore, if x is not equal to 1 and x is not equal to 2, even if it is not given, it is there in the statement of the problem. Therefore, 1 and 2 will continue to remain hollow and 3 will become dark circle. Okay, it is extremely important. If you keep 3 also hollow, then your answer is wrong. If you make one dark circle, it is wrong. Therefore, solution set for this problem is open interval minus infinity to open interval 1 union open interval 2 to closed interval 3. This is the solution set. Hope you are understanding this very well, and now you are ready for the little more difficult problem. Change color. Example number 3. 1 upon x square minus 7x plus 12 is strictly less than 1 upon x square minus 6x plus 5. Get me the solution set. Okay, this is relatively difficult problem because it has too many terms. So let us understand how to solve this step by step. First of all, both the denominators are good looking and they get factorized. What are the factors of this? X minus 3, x minus 4. Now I can bring the RHS term to LHS by changing the sign. X minus 1 and x minus 5. Is that right? This should be less than 0. This is acceptable. Adding negative of this term to both sides of inequality will not change inequality. RHS will become 0, LHS will become this. Now, this is first step. First step. First level of difficulty is bring RHS to LHS. Second level is okay, cross multiplying, get everything in place. X minus 1 LCM, x minus 3, x minus 4, x minus 5. What is the numerator? For numerator, maybe we can use these two terms, x square minus 6x plus 5 minus x square plus 7x minus 12. That is what is going to be the numerator, which is x square 1 x minus 7 divided by x minus 1, x minus 3, x minus 4, x minus 5. Right? Should be less than 1. So this is second, this is first, this is second. I am just checking how many jumps you have to take to arrive at final answer. And that is, if the number of jumps are more, the problem is difficult. Number of jumps are less, then the problem is easy. Okay, so now we have reached the stage where we can apply our first couple of problems trick, which is make the denominator positive. That will give us x minus 1 into x minus 3 into x minus 4 into x minus 5 into x minus 7 upon denominator square should be less than 0. Cross multiplying, we get this. Okay. So if we are solving this, we can draw the wavy curve and answer. However, if equality was allowed here, then it would have been still little more difficult problem, because strict inequality is there. If we are solving this problem or if we are solving this problem, does not have any difference in the solutions. So now we have this. Let us draw wavy curve. 1 hollow circle, 3, 4, 5, 7. Now if you take extreme left, suppose you put x is equal to 0, which is to the left of 1, scanning from left to right. So x is equal to 0, minus 1 into minus 3 into minus 4 into minus 5 into minus 7. You need not have to do multiplication. You have to just check the sign. It is going to be negative because all brackets are negative and there are odd number of brackets. Therefore, the graph will enter like this from negative infinity. Then it is wavy. This is how the nature of the graph will be. As simple as that. And you are interested in less than. Therefore, this is what is the value of x you are interested. This is the value of x you are interested. This is the value of x you are interested. Therefore, solution set minus infinity to 1, open interval, union, open interval, 3 to 4, open interval, union, open interval 5 to 7. Okay, so it's a 3-jump problem and hence little difficult compared to earlier problems. Okay, so now let me just to make you happy, let me change the numbers and give you yet another problem so that you will feel happy about yourself. Example number 4. 1 upon x square minus 7x plus 10 is greater than equal to 1 upon x square minus 6 is 8x plus 7. 8x plus 7. Find solution set of this. This is exactly similar to earlier problem, except there are two things which has happened in this problem. One is equality got added, and once you cross multiply and simplify, you get a factor which is little different looking factor. So let me write down after cross multiplying what you get. You get minus x minus 3 into x minus 2 into x minus 5 into x minus 1 into x minus 7. This should be greater than or equal to 0. That is what you get after first step. First step is take to the left. Second step is make the denominator perfect square. So those two steps if you perform, then you will get into this and then cross multiply. Okay, this is what you get. Now it is really difficult to deal with this, so you have to be absolutely simple about it. Minus 1 taken out common from this, it is available, and then it becomes x plus 3. So x plus 3 common critical point is minus 3. So this is going to be the smallest integer. Then the next smallest is x minus 1, x minus 2, x minus 5, x minus 7 should be greater than or equal to 0. Out of which this bracket is because of the cross multiplication and simplification. All these brackets are because of making denominator perfect square. Okay. Therefore, I am just putting a star mark here to understand that this x is equal to minus 3 could be acceptable as far as this equality is concerned, but x is equal to 1, 2, 5 and 7 are still not acceptable. That is why I am just putting this star here. And therefore, now if you practice this, you should be able to quickly write down the solution set and maybe quickly draw the diagram also. Leading coefficient is minus 1 multiplied by everything. Okay. So critical points minus 3, 1, 2, 5, 7. If we take any point to the left of minus 3, all these brackets will be negatively signed and therefore product will be negative. When you multiply negative product of 5 brackets with minus 1, you will enter the graph like this. And then no bracket is repeated, every bracket is different, therefore it is simply wavy curve like this. You may cross check in the end. If you put value of x greater than 7, say 8, positive, 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 all 5 brackets are positive, multiplied by minus 1 will become negative and hence this will disappear to negative infinity. Now you, because of this star mark, equality, if you take care of equality, you can make this as a dark circle and remaining all 4 will continue to remain hollow. And you want greater than, therefore solution set is going to be this, 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 and in terms of intervals it is minus infinity to minus 3 closed union open 1 to 2 open union open 5 to 7 open, as simple as that. Okay, so now there is no point in solving one more problem. These two problems should be sufficient for you to understand the solution set. If every bracket is present one number of times, only once. If there are repeat brackets, then we have already solved out that kind of problems in last lecture. So now let me change the texture of the problem. Example 5. Example 5 is find all values of A for which x square plus ax minus 2 upon x square minus x plus 1 less than 2. Revision. I will draw sketch of quadratic equation. Suppose the graph of quadratic equation is like this, and the equation is x square plus bx plus c. Then what can we say about the graph? If ax square plus bx plus c is a quadratic equation whose graph is looking like this and this is x-axis, then what does it mean? Can we recollect?
A is greater than 0.
A is greater than 0 and delta is greater than 0, right? So this is what was our first graph. Second graph like this. Third graph like this. What was this? A greater than 0, delta is equal to 0. A less than 0, delta is less than 0. Now, so if the graph is like this and if this is x-axis, what is actually we are trying to say? For any value of x here, what will be the y value? Y is equal to x square plus bx plus c. If I take x is equal to this value, what will be y value? Is positive or negative? Positive. If I take this value, what will be y value? This, positive. If I take this value of x, what will be y value? Positive. Positive. For every value of x, you have positive value of y if the graph is totally above x-axis. If the graph is touching, then only one value of x will give you value of y equal to 0. All other values of x will give you positive values of y. And here, if I want positive values of y, then these are the points which will give me positive values of y, these values of x, and between this I will not get. It is as simple as that. Now, the remaining three graphs are like this. What do we mean by this? A less than 0 and delta greater than 0. If the graph is like this, a less than 0, delta equal to 0. And if the graph is like this, a less than 0, delta less than. What do I mean by this? For every value of x that you take, y value is going to be less than 0. For every value of x except this point, y value will be less than 0. And for these values of x, y value will be less than. That is what is the meaning of these 6 graphs, and they are extremely important. Everywhere you will come across understanding of these 6 graphs. Now let us solve this problem now. The problem statement is this inequality. And what is so good about that inequality is, okay, let us see. What is this denominator? X square minus x plus 1. Is it a quadratic equation? Yes. Is the leading coefficient 1? Yes. So positive? Yes. So one of the three, these 3 graphs it will be. What is discriminant of this? 1 minus 1 square is 1 minus 4 is equal to minus 3. So delta is equal to minus 3. A is equal to 1. So the graph of this function or this quadratic is like this. So for every value of x, value of y, that means value of this denominator is always going to be positive. Therefore, even if it is present in the denominator, we are not worried about it. We can directly cross multiply. X square plus ax minus 2 is less than 2x square minus 2x plus 2. We can do this because denominator is positive for every x belonging to real numbers. This is first important step. Now we have got inequality with us. So maybe what we can do is you can put this fellow that side, and hence we will get x square minus 2 plus a x plus 4 is strictly greater than 0. Now you want this quantity to be always greater than 0 for any value of x. That is the requirement of this problem. Find all values of a for which this quantity should be less than 2. That means find all values of a for which this quantity is always greater than 0. Is leading coefficient positive? Yes. Therefore, we want this kind of graph of this left hand side. And if I want this kind of graph of this left hand side, might as well my discriminant, which is going to be equal to 2 plus a bracket square minus 16, might as well it becomes less than 0. So if we solve this, if we expand this, we will get a square plus 4a minus 12 should be less than 0. So what values of a will give you LHS less than 0? So we are solving the quadratic, we are solving the ratio of quadratic equations. We ended up getting a quadratic inequality. We want to solve quadratic inequality for finding out values of a. We ended up one more quadratic equation. We are supposed to solve this quadratic equation now for values of a. So a square plus 4a minus 12 should always be less than 0. So a plus 6, a minus 2 should be less than 0. Now at this stage, we have got the problem which we have solved earlier. So maybe 1, 2, 3, 4. 4 jumps. And we got earlier. So couple of more jumps here. So the critical point is minus 6 and plus 2. Strict inequality, both of them will be hollow. Leading coefficient positive, it is going to be graph like this. You want less than, therefore open interval minus 6 to 2 open interval is your solution set. Let me know if you have not understood this step. Next problem. %56 up. Example number 6. X square plus 3x plus 1 into x square plus 3x minus 3 should be greater than or equal to 5. Find all values of x such that this equation is satisfied. Substitute x square plus 3x as y. LHS factorize. Take this 5 also to LHS and factorize LHS in terms of y. Then substitute back y is equal to x square plus 3 and do further factorization and solve it. That is the way to go about it. Wait for a couple of more minutes. This is y plus 1 into y minus 3 minus 5 should be greater than equal to 0. So y square minus 2y minus 3 minus 5 is minus 8 should be greater than equal to 0. So y minus 4 y plus 2 should be greater than equal to 0. X cube, sorry, x square plus 3x minus 4 x square plus 3x plus 2 should be greater than equal to 0. X plus 4 x minus 1 x plus 1 x plus 2 should be greater than equal to 0. Then graph, the smallest value is minus 4 minus 2 minus 1 1. No denominator anywhere, all equality, therefore dark circles. 4 brackets, leading coefficient positive will enter from here, go here, go here, go here, go here. You are interested in positive, minus infinity open, minus 4 closed, minus 2 closed, minus 1 closed, union 1 plus. Example 7. X square minus x minus 1. X square minus x minus 7 less than minus 5. Exactly similar, you have to do it. Every one of you should get it. Okay, this need to be solved exactly similar way. So I am not writing the solution, writing the answer. Bola, what is the answer?
Open interval -2, comma -1, union open interval 2, comma 3.
Okay, last question of today's lecture. Example 8. Five x Okay, this is today's last problem and homework. I will write couple of problems. One, so write down the 6 problems for homework. Solve these inequalities. Find the solution set. That is what is the statement of the problem. And if you cannot solve this problem today, then that is also the homework. We will discuss it in the next lecture. I can subtract, so 5x plus 4 upon x plus 3 minus x plus 2 upon x less than 0. I can cross multiply, so 5x minus 5x square plus 4 minus 4x minus x square minus 2x minus 3x minus 6 divided by x plus 3, 1 minus x is less than 0. So minus 6 x square 8 minus 4x minus 2. So now if I make everything plus divided by x plus 3 x minus 1 is less than 0. I can remove 2 and I have to check whether it gets factorized. So 2 into 3x square plus 2x plus 1, which is 2 into 3x square minus 6x plus 4. minus 4x minus 2.
Sir, it cannot be factorized
Okay,
actually.
plus 2x plus 1. So it is
Sir, but it is always positive,
this
so
is
it
always positive. So multiply by x minus 1, x plus 3 makes the denominator x plus 3 square minus square should be less than 0. This is positive, forget about it. This is positive, forget about it. So practically this will decide. Critical points minus 3, 1, positive opening up, solution set minus 3, comma 1. This is the solution set. That is how it needs to be solved.
Sir,
Yes.
so how is 3x squared plus 2x plus 1 always positive?
What is discriminant of that? Discriminant of that is 4 minus 12, which is minus 8, negative. Leading coefficient positive. So the graph is like this.
Thank you, sir.
सर
Hmm.
मायनस 6x² मायनस 4x मायनस 2चं आपण सगळं प्लस केलं तर मग त्या मायनसचं काय झालं
इथे हे फ्लिप केलं ना x minus 1.
हा